Okay, today I'm going to talk about the law of mass action, which is also known as the law of equilibrium. This is also known as wait, okay, so law of equilibrium. This is also known as law of equilibrium. So same as law is written as same as equilibrium. Law of equilibrium, known as law of equilibrium. I would say that by writing with it is the more appropriate. So let's just clear it up. So I'm going to write it directly. It is law of equilibrium, right? So, law equilibrium, right? The law of mass action is also known as law of equilibrium. So, yeah. So let's just make it highlight so that it will be visible. The law of equilibrium, right? So now I'm going to talk about what is law of mass action. According to law of mass action, uh, the rate of reaction is directly proportional to the active masses. Rate of reaction is directly proportional to the active masses of the reactant or a product. Actually, when these two brackets are written, something like this, and some reactant or product, this is written inside it. This is basically known as active masses. So this is known as active mass. This place is known as active mass, right? So according to this law, the rate of reaction is directly proportional to the active mass of the reactant or a product. For instance, the reaction is written, which is something like this. For instance, this A plus 2B gives C plus 3. B is equals to B. B gives 3C. I'm facing some problem by writing it. Plus God. D. So how we're gonna write it? Now I'm gonna write about their forward reactions and the backward reactions. So first of all, I would say that, for instance, A plus 2B, right? So this is basically known as forward reaction. So it will be written something like this. As I said, their moles will serve as exponent powers, right? So uh, rate of forward reaction is directly proportional to the reactive mass of A with power 1 because its mole concentration is you would say its mole their moles are 1, so it's 1 and then 2, which means that will be written inside the bracket with the power 2. So this is rate of forward reaction, and when you remove it you will get some sign which is equals to kb kf, which means k forward reaction is equals to A and concentration of not concentration but the active mass of A and then the active mass of B, right? So this is basically rate of forward reaction and rate of back. Now we're going to write the rate of backward reaction. So let's move a little down. Okay, just write it here. Next, rate of backward. So rate of backward reaction. B. Rate of backward reaction is directly proportional to concentration of C. As you can see here, the moles are 3. So let's just write 3 moles. Oh God, I don't know what's happening to my keyboard right now. So it's letting here. I don't know. Okay, just remove it. Now I'm gonna take it again. Concentration of C with power 3 and then B with power 1. So this is forward reaction, and when you remove it, you'll get a constant which is Kb, constant of a backward reaction, right? So this is constant of a backward reaction. Everything is same, right? So rate of forward reaction and rate of a backward reaction, which is the equilibrium constant. This is the equilibrium constant of a forward reaction. This is of a backward reaction, and they together known as Ke, which means forward and backward together is known as Ke, which means the equilibrium constant of the equation that we have written on the chemical equation, the equilibrium constant, right? So Ke is the equilibrium constant, and this is basically a ratio of the forward reaction to backward reaction. This is a ratio of forward to the backward reaction, Kp, right? And this can be described by two ways. The one way is to describe this equilibrium constant. Let me just move in. I'm going to explain you here. So there are two ways basically to describe it. Hmm. Yeah. So the first one is molar concentration. For example, K is the equilibrium constant. So there are two ways, right? So first is molar concentration, which is number of moles per unit volume, molar concentration. And the second way is partial pressure. Now, what is mean by partial pressure in terms of gases? The way is partial pressure in terms of gas, I would say. In terms of gas. So how is it possible? So first of all is PV is equals to nRT. PV is equals to nRT. nRT. Oh God. So when you shift here, so P is equals to N divided by VRT. N divided by VRT. NV is equals to NV means number of moles per unit volume. So indirectly the partial pressure also describing the molar concentration, but the mass action, the active mass, which is anything written inside the bracket, can be described by two ways. The one is molar concentration, another one is partial pressure.